What's up, everybody? Axe Wizard here. Gonna work on my game some more, and I'm excited because last episode I made the decision I'm gonna stop working in GameMaker and port my progress over to Godot. And since then, I've been doing a lot of research. I found a really helpful article about this fine person here made a GameMaker to Godot thing and kind of gave some tips on how to translate your GameMaker knowledge into working with Godot. So I feel like I've absorbed as much as I can without losing a bunch of stuff. So what I'm going to do is I'm just going to switch to 2D here. Let's get started on porting stuff over. So the only thing I've done so far is I imported some sprites. Like I copied some sprites over. That's all I've done. So let's tap into the magic of Godot. Now, it's very different than GameMaker, but in a lot of good ways. And I think when we start, the first thing I want to tackle is I want to start re-implementing a ship, like getting ship movement and stuff done. So I think we can recreate a lot of that stuff. And when it comes time to do weapon systems, I think that Godot is going to make that a lot easier than it was in GameMaker. So first things first, let's create a root node. We're going to create a 2D, and this is just our root node. I'm going to rename this to root. So this is like the entry point for our game. So this root node here, this is what determines like what is shown. So now that we have a root node, I'm going to save this. It's going to ask me how I want to save it. I'm going to save it as a root.scene. Save. There we go. So now what I want to do is I want to create a new node. So we're going to do node 2D. Again, nodes are like Legos, right? Like every one of these little pieces does something different. So I'm thinking I might want to do, let's see, do I want to, I think I'm going to use a kinematic body 2D node, which is going to take care of physics, which means that the code of me moving around is going to be different than it was in GameMaker. Where GameMaker, I was just basically manipulating just the straight X and Y values, whereas this will use vector math, which is entirely different and something I'm not really familiar with, but I know that this is the way to go. So I'm going to do a kinematic body 2D node. And what is this? Node has no shape. Okay, so first thing I'm going to do is I'm going to rename this ship. Okay. And what we're going to do is I'm going to add a child node. And this node is going to be... So they wanted a collision shape. But the shape is going to differ depending on the sprite. So that's going to be fun. So let's cancel that for right now. So consider adding a collision shape 2D or a collision polygon 2D as a child to define its shape. Okay. So first things first, let's add a sprite. To this, I think it's canvas layer. No, node 2D, sprite. Create. So we added a sprite to it. So if I right click on sprite and I go to open documentation here, it just pops open the documentation like right in the editor, which is awesome. So what we'll do here is we'll just, I'll just go to Godot, add sprite. Drag your image from the file system doc and drop it in the texture property. Okay. So what we need to do here is, since we have sprites already, we just need, let me go back to the 2D here. So sprites, generated, ships. We'll just do ship 1 and I'll drag it into the texture property. There we go. So now we have a sprite for our ship. Fantastic. And so now what we need to do is we need to, let's see, we need to add a child node and we needed to add it was a collision object. So collision shape polygon. Create. So now no configuration warning, an empty collision polygon 2D has no effect on collision. So I wonder if this means that ships are going to collide with one another. If that's the case, then that's not what I want. In which case we probably want to actually get rid of this node. Delete node. And I'm going to change this. I'm going to change the type of this node to just a standard 2G, because a 2D has a position, rotation, scale, and z-index. It's a lot of what we had before. So cool. So we have that. And now we have our sprite. So just like a basic game maker, like the ship here, this is our sort of like our object. Now, see, the nodes work. Every node is basically a little mini object. So rather than having everything just be obj ship, we have a bunch of like we have basically just a big Lego figure, right? So for ship, we have a sprite. What I'm going to do is I'm going to add a script to this ship, and I'm going to save it as ship.gd for Godot file or whatever. So there we go. So now we have our script. So this is sort of like where we do our code, like in GameMaker here. This is sort of where we do our code, except rather than having stuff in different events, like a step event and a create event, we just do everything in one. So this is sort of our create event, really, or ready, when the node enters the scene tree for the first time. And then this process delta, this is this process function here. This is our step event, basically. Hey everybody, it's been a few days since what you just saw. So to get you up to speed on what happened, I basically spent like 2 more hours floundering through trying to get movement to work, and I didn't really understand vectors that well, and I still feel like I don't, but I think I have a basic grasp on it. So after that 2 hours of floundering, I felt pretty defeated. Like, you know, I was all gung-ho on switching to a new engine, like, oh, this will be easy, ship movement, because I was able to knock that out in like a few minutes in GameMaker. Well, that's because I know GameMaker. I don't know Godot, and this is the first time I've really worked with vector math before. I didn't quite understand how it was working, but now I do. So I've done a few things. So like if we go to like the help manual, like the 2D movement overview, I was kind of following along with what they did. So the first thing I did was I already did my input map. So if we go into Godot and we go to the project settings, input map, you can see these ones here, ship accelerate, decelerate, rotate left, and rotate Y, or rotate left and rotate right. I added those here as just WASD for now. So I added the ship input, and then in their little examples here, you know, it shows that they're using kinematic body 2D, and you know, they're basically changing their X and Y. They were creating a variable called velocity, which they make as a vector 2 type, which is just a type that stores an XY pair. And so I thought, okay, well, we're just moving our X and Y. That's easy enough. So you can see we're increasing our X-axis to move to the right. We're decreasing our X-axis to move to the left. That's exactly like what we were doing in GameMaker. We're increasing our Y to move down, and then we're decreasing our Y to move up. Exactly like GameMaker was. So I thought, okay, cool. And then this is kind of where I started getting confused. So they do like a velocity dot normalized times speed. I didn't know what this was. And then this is where they actually apply it. They do a velocity equals move and slide velocity. So I was like, okay, well, I don't really want the ships to like be colliding with each other, and like, you know, if they're going here, I don't want them to like slide off and do that. So I kept going, and it's like, okay, rotation and movement. This is kind of what I want. Not really, actually. That's not really what I wanted at all. So I ignored that one. Rotation and movement plus mouse. I guess this is closer, like you're basically moving towards wherever you're facing. So I was looking at their code example here. Again, they're creating a vector 2 and saving it as a velocity variable. I didn't understand this at all either. I was like, what are they even doing here? I don't understand what all this code does. So I wasn't really getting it. And then I started looking at their tutorial on like vector math and trying to explain that, and it took me a few reads of this to actually get it to click, and the thing that actually made it click was a stupid movie called Despicable Me that I would watch with my son, and there's a villain in there called Vector.
Go by the name of Vector.
And there's this line he says.
It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
And for some reason, that made it click. So when I was coding the stuff, I didn't quite understand. Like, I thought it was just X and Y, like we were just setting our ship X and Y, like the Vector 2 was just holding that. But no, the vector is actually just the, it's just the offset from a relative point. So if this diagram here shows it, like if we have a vector 2 that has a value of 4 and 3, an x of 4 and a y of 3, then that's not just that's sort of like determining where we're going to go, but also there's a lot of things that you can do with the vector 2 type that gives you the direction and the magnitude.
Because I'm committing crimes with both direction and magnitude. Oh yeah!
So all that stuff that I was doing in GameMaker, like when I was doing my weapon slots and my weapons, where I had to like calculate what the offset was, and like so that way I can manually rotate it, that was basically a vector that I was sort of remaking on my own. Well, once that clicked, I kind of understood. So let's go back into the code, and you can see what I've done here. So I've zoomed in, so the code should be readable. Here is where I'm determining all my variables. So I've got, I'm just creating a velocity, which is just a vector 2. I like the fact that you can also declare what type you expect. So that's the approach I took here. So in my code, you'll see me trying to enforce type safety. That way it helps prevent bugs. It's not something that's needed in Godot, but I love the fact that they have support for that, because one of the main languages I'm used to working in is called Go, and Go is like a statically typed language, and it's I'm big on type safety. I love it. So yeah, so I've got the velocity, which is basically storing like what are it's the vector that we're going to be applying moment to moment. So if you look farther down here in the vector code, they even have like a little spaceship here, a top-down spaceship. Oh my god, that's exactly what I need. So your position is a vector 2 type, so you can add two vectors together, which is shown here. You know, there's two vectors that they're adding together, and you can see the result of that. So what we're going to be doing is we're basically going to be just translating our velocity, which is how I'm using it. It's sort of like our motion. So in GameMaker, if we bring up that code here, so here, like, we're checking if we're pressing W, and then we're going to accelerate in the direction. We're doing motion add. I'm sort of doing that with vectors in Godot. So, and then I also have a variable to keep track of what my rotation is. One key difference is that this is in radians, not degrees, and I was not familiar with radians. So if you're not familiar with radians, a radian is basically equal to 57.2958 degrees. And apparently it's a pure measure based on the radius of a circle. And I had never used radians before, but I guess a lot of engines use radians because it's a lot easier to do a lot of the more complex math behind the scenes. So Godot does have the option to convert degrees to radians. So I decided to just use radians, just embrace it. Why not? So this is the current rotation of the ship. I've got that set, and then now I'm defining my acceleration speed. You know, it's basically the same thing that we were doing in GameMaker here. Like, you know, we have our acceleration speed, we have our max speed, turn speed, deck speed. It's just that the only difference is, rather than GameMaker having a direction and a speed variable built in, we're controlling that with our vector 2, which is our velocity. So, and we also have a keeping track of the rotation of the sprite as well. So, because our velocity of where we're moving is going to be different than where our ship is facing. So, yeah, cool. And then, yeah, so turn speed, deck speed, all that stuff. Again, in radians, not degrees. I'm not sure the unit of measurement, but I was playing with some numbers and I just settled upon those. So this little func ready, this is sort of our create event. I don't really need to declare variables in that create event. There's some use cases for that, but I haven't run into that yet, but that will come eventually. So then this is our process delta. So this is effectively our step event in GameMaker. So what we're doing here is I am just preparing a fresh vector 2 that I'm going to use to add motion. And then from here, I'm getting ship or player input. And the first thing I'm tackling is whether we are rotating our ship or not. Because the rotation is also going to determine how our vector 2 is established. So, is action pressed? So input allows us to tap into input. Is action pressed as a method of that? And you can see here that I've got my input map that I added earlier. So ship rotate left. Go back to our project settings. You can see ship rotate left is actually A. So we've got that set there. And what we're doing here is we're subtracting our turn speed time multiplied by delta. So delta is the elapsed time since the previous frame. So what this lets you do is that you can your game will be more resilient if you have something like frame skips due to something like out of your control. So say if someone's computer just, I don't know, maybe they installed that stupid McAfee antivirus and it's just bogging down their system, and instead of getting 60 frames per second they're getting like 35. Well, it's still going to give you the same result. So, yeah, so that's what we're doing there. Now, the interesting thing here is that to turn left, we're subtracting, whereas in GameMaker, we would actually be adding. So direction in GameMaker is counterclockwise, direction in Godot is clockwise. So that's kind of cool. So rotate to the left, counterclockwise. We're just subtracting our turn speed multiplied by delta. So, for example, our turn speed here is, this is basically the rate in radians, not degrees, at which the ship can rotate in a single second. So, if I'm expecting, 60 FPS or whatever, say if the game is running at 120 FPS or if it's running at 30 FPS, it's still going to turn the same rate. So, that should work fine. And I got this number by converting, if we go back to GameMaker here, we had our turn speed. So this was basically, so turn speed was 1. So how GameMaker was doing it is it gives you roughly 60 steps per second. So my ship was turning roughly 60 degrees. Well, I just converted 60 degrees to radians, which is 1.04 or whatever radians or whatever it was. Yeah, 1.0472. So that's where that number comes from. So now that we've got our rotation handled, now I'm tackling acceleration. And I'm just checking if we are pressing the ship accelerate. And what I'm doing here is I'm getting the new vector of our intended motion, taking into account the rotation and acceleration speed, or direction and magnitude. Thanks, vector.
Oh yeah!
So here I have a function that I made called getMotionVector, and that is just down here. And this is something that I actually found in that GitHub README that somebody made. Yeah, here it is. So like length direction, right? So basically what they're doing is they are taking a vector 2 and they are initializing it to 1, 0. So what that means, if we go back to the Godot documentation on vector math, let's pop up and paint really quick. So if we have like a basic grid, right? So say that this point right here, let's just make this a little easier here. So do this. So here is our X, here is our Y. Okay. So top left is 0, 0. So vector 2, if we have a 1 and a 0, that means that our X is 1 and Y is 0. This will give us a blue line here. Let's make this like lime green, so it's easy to see. This will give us a arrow that's basically pointing to the right. So then what they're doing after that is they're doing a dot rotated method, which will rotate the vector, and it will calculate the new x and y for that. So it rotates it based on where we're supposed to go. So for example, if we rotated, let me go back to paint. So if we rotated, say 90 degrees, or like whatever that would be in radians, and we pointed it down, then that would give us a new vector of 0, 1. Now this is a really simplified example, but because the x and y of a vector 2 are floats, they support decimals, it just keeps it clean for conceptual reasons. So if it's pointing down, that gives us a new direction. And then what they're doing after is they are multiplying it by the desired length, which is your magnitude. So direction and magnitude. Ta-da! So then say if my length is 5, let me just say here, vector 2 is going to be 0, 1. And then if you multiplied that by, your magnitude, say that's 5, that would give you a vector 2 of 0, 5. Or that would give you a new vector of 0, 5. Which, if we go back here and we get our little handy-dandy thing here, that makes us go, whee! Right? That gives us another vector, which again is just the offset from a relative position. So 0, 0 is our position, and then whatever the vector is an offset from that. So what's happening in the code here is that I'm setting this motion to what my current rotation is, and my acceleration speed multiplied by my delta. And I'm saving that as this vector 2 here that I created. So this is, so every time process is called, or every step, it's creating a separate vector 2, and we're calculating our motion based off of that. Now I haven't figured out how to decelerate yet. I'm still working on that. And then what I'm doing is I'm handling my sprite rotation separately, because I don't want like my movement to be tied to like the direction I'm facing all the time, just only when I'm accelerating. So that way I can drift through space. And then what I'm doing is the velocity variable that I have up here that I'm keeping track of, I'm adding our motion to that. So that's kind of basically like in GameMaker where we were doing motion add. That's sort of that same logic. So again, this is the funny part. Image angle is a direction. The acceleration speed is the magnitude.
Direction and magnitude.
So we've got that going on. And then what I'm doing here is I'm doing a self.translate, and I'm basically moving myself to my new velocity. So since I'm keeping track of this velocity all the time, not just in the scope of just the step event or this process function, that allows me to basically freely float through space. So if we run the game, we have similar stuff to how we had before, to where I can turn, and if I accelerate, I'm floating through space. Right? Now, I don't have a way to cap like the top speed yet. Still working on that. And I don't have a way to decelerate yet. But I'm getting better with vectors. So that was a lot. This meager amount of code took me an ungodly amount of time to actually figure out. But I think I have a pretty good understanding of it. Let's figure out how we can actually, let's see, let me see here. So vector 2, where is that? So if I hit control and I can click on something, I can click on vector 2 and I can view the documentation for it. So does it have a way to get what the current like magnitude is? I guess length. I guess the length is what that is. Length returns the magnitude of this vector. Okay. So what we could probably use that. So what we can do here is when we calculate our motion, like we add our velocity to it, what we can do is ensure our velocity does not exceed our maximum speed. So then what I can do is if, and I can do velocity dot length, because that is a velocity is a vector 2, and I have access to that method, is greater than, and I'll have to make a variable probably. I will. So let's do the maximum magnitude this ship can travel in a given. We're gonna have to do it like in a second. So, and we're gonna have to leverage our delta just like we're doing with the other stuff here. So I'll say var, and I'll do max speed, and I will set this as a float, which is a decimal. And let's see. So let's go back to GameMaker here. So let's look at what our code was. So max speed here is 4. So if this moves 4 pixels per step in GameMaker, and there's roughly 60 step events per second. So 4 times 60, that's what, 240? So this should be 240. And what we can do, now that we have that set, we can say move our ship using our updated velocity vector. Wait, no, it's here. I think that this should work, but yeah. So what we'll do is velocity. We'll probably have to. Let's see. Can we set the length? How I set its magnitude or length? You must first normalize and then multiply by your target size. Okay, so normalized. Okay, so let's give that a shot. So what does normalized do? Returns the vector scaled to a unit length, equivalent to v divided by v length. Vector divided by vector length. Oh, I gotcha. So it just... Okay, normalizes it. Gotcha. So let's go back into our code here. And we'll say velocity equals velocity.normalized, and then we will say times max speed times delta. Okay, and I think that should put a cap on it. So if we run the code now, this could be entirely borked. Come on. No, it worked. Yeah, we're moving at a max speed. We're not able to accelerate more. I love it when I get it. Cool. So let's comment what we learned. That way I know in the future. I mean, I'll probably know in the future, but you know, I would rather have too much comments in code than too little. So normalize the vector so that we can set its magnitude. Instead of set, maybe we can cap the magnitude to our max speed. So that works for me. Cool. So I think what we can do to do deceleration, we just need to basically slow it down. Let's bump this up to 0.5 so we can see if it's doing something first, and then we can adjust that rate if needed. So let's do deceleration. So if input is action pressed, we want to see if it's doing it the entire time. Autocomplete has my built-in input mapping, so ship decelerate. I love it. So now we can decrease the magnitude of our vector. So what we can do here is we're gonna, instead of doing motion here, just modify velocity directly rather than calculating a change to the motion, because we're not really wanting to like thrust in a new way. It's just whichever way we're going, we just want to just slow down. So we will work with velocity, and then we will say velocity equals velocity normalized. Wait, no, let's do velocity. Can you subtract from a vector, or can you like only multiply it? So let me go back to vector math here. Vectors. Okay, vectors can be multiplied by a scalar, so we cannot just add a non-vector to a vector. So we need to actually scale it, is the problem. Okay, so here's what we have to do. We have to get the current length of the velocity as it is now, and then subtract subtract our deceleration speed, and then we have to normalize the velocity and multiply it by that amount. So let's do var. I'll just say new new speed equals, and I will say velocity length minus, and we will say deck speed multiplied by delta. So there we go. So now we have new speed. So now what we can do is velocity equals velocity normalized, and then we can multiply it by new speed. And I think we also need to make sure that ensure new speed is not a negative, because we don't want to like slow down and then like start going the other way. We ran into that problem before. We want to make sure that we just slow down to a stop. So ensure new speed is not a negative. So what we can do is if new speed is less than 0, we can just say new speed equals 0. Okay? So that way we are never going in the negative, so that's good. And now we will apply the new speed to our velocity vector. Save. Okay, so let's see if this works now. So let's save. Okay, so I'm moving, and if I hit S, I think it worked. Yeah, it worked. I thought I was moving for a second still. Okay, so let's speed up and then slow down. That works. All right. I'm getting vectors, baby. This is exciting. Cool. And the other great thing about learning vector math is like that other big engines like Unity I know uses vectors. When I tried that a while ago, I think vectors was one of the things I just didn't understand and turned me off of it. But I think I'm at a point now where I have enough patience to actually research this stuff and learn it. So I'm pretty happy. I haven't messed with Unreal, but I'm sure it uses probably vectors and stuff like that too, but who knows. So good stuff. Yeah, there we go. We've got ship movement. Fantastic. Now let's clean up our node stuff here. So right now I just have my root scene, and then I have my ship, and then I have a sprite attached to it. So I want to make this ship its own scene so that I can like instance it and put it like wherever I want. So let's just see, right click. I don't want it to make it the scene root. Save branches scene, maybe? Ship scene. There we go. Cool. So now basically I have a ship. So if I want to, I can add more ships whenever I want. So cool. So we've got that. Now if we go back to our game, like what else do we got? So let's run the game here really quick. So obviously we have our title screen. So we'll get to that. But in like our testing area, we have, you know, weapons for our ships and stuff like that. We have a cursor, we have a background that is parallax. So I need to figure that out. So let's hope that's not as big a deal as it was in GameMaker, because I think that was like 2 episodes of me just grinding through a bunch of trash. So yeah, let's figure that out. How do we do... I was looking at parallax backgrounds earlier, and I think that they have a node that will just work for that. So let's do Let's add a child node. And let's search for parallax. So we have a parallax layer. We have a canvas layer, parallax background. A node used to create a parallax scrolling background. A parallax scrolling layer to be used with parallax background. Okay, so let's make a parallax background. And we will say, yeah, we'll just leave it as parallax background. That's fine. So let's add a, let's see, scroll. Is there a way that we can, because every parallax tutorial I watched, or like the code I saw, was the parallax was going on one axis only. I want it to go on both axes, like wherever I'm traveling. Well, let's just add a child node to this parallax background. Let's make just do a parallax layer. Okay, one thing I realized that we're going to need is that the parallax background apparently needs to work with a camera. So in my ship code here, what I want to do is that we probably want to also determine if we are the player or not. So determine if we are the player or not. And what we can do here is, this might not work, but I can probably tweak it later. There's a few different ways that we can handle this. So I'm going to say var player equals true. And what I'm going to do is I'm going to say is that in this on ready here, we are going to say if player, again, player is a Boolean, so it'll evaluate to true or false. So if true, if player is true, then we want to, what I basically want to do is I want to attach a camera node to our ship. So how do we do that? Let's see. Okay, so it looks like I can just do something like a var camera, which we're going to specify as type camera, camera 2D equals, and I think we can just do camera 2D dot new. Okay, and I want to basically add a camera to my ship, I think. So let's go back to the code here. And then I will say self.add child, and we will say camera. So let's just see what this does, like if this even runs. Okay, cool. So we have that. So we're making a camera 2D. Okay, so attach a 2D as a child of your player and set its current property to on. Okay, so let's go back to Godot. Let's look at the current. So that's a Boolean, so that'll be true. So what we need to do here is not GameMaker. In Godot, we need to camera dot current equal true, and we're going to add child. Let's see if it works now. Okay, so our camera is now following our player. It looks like we're just not moving, but that's just because the camera's following us. So we have a active camera. That was easy. I love Godot. This is great. So now let's go back to our parallax problem we were working with here. So, okay, so we need to add a sprite as a child of our layer here. So add child node, sprite. I love how this works. This is just so great. Oops, I wanted to add it as a child of parallax layer. There we go. So the sprite that we need, if we go back to my resources I imported, backgrounds, let's just do BG2 for now. Import that. Offset, I don't think it needs to be centered. I don't know if it matters or not. But let's see what it does now. Okay, so yeah, we're definitely moving. But, okay, cool. So that's not doing anything, but if we go to import here, repeat is enabled. The camera is placed as a child of the background. So it needs to be a child of the background. So what we need to do is we probably need to go back to scene here. What if we make ship a child of the background? Okay, it's kind of working. Like you can see that the rate at which the parallax background is moving is different than the actual ship moving, which is good. But it's moving a bit too fast is a problem. So let's fix that. So I'm sure that there is some sort of layer transform. So I think the parallax layer is what actually, so if we go to open documentation, that's what's controlling him. So motion scale, motion offset, motion mirroring. So I think motion scale, we can probably set that to be much less. So right now it's like a 1-to-1. It's basically like mirroring our current vector, like wherever we're moving, I think. So we need to set that to be a fraction. So what we can do here is motion scale. Let's just do something like 0.2. And then we'll do 0.2. Save, and then we'll see what that does. There you go. So now the background moves a lot slower than it was before. So that's fantastic. Let's make that 0.3 maybe. 0.3, save. Run it. Yeah, I think that looks pretty good. But now we need to make it so it actually tiles. So how do we make a parallax layer tile? Motion mirroring property of the parallax layer node. The image is used for a parallax layer. Motion mirroring. So we just have to set it to be the same dimensions as the sprite. So if we set mirroring to be 512 by 512, I mean, it kind of works. But then our camera's all borked. So we want to undo that. Run it. But our camera's not following our ship anymore, though. So I don't think we want the camera to be a parent of that. But then it doesn't do anything, though, is the problem. Well, this will be fun to figure out. So we have to specify a region. So if we did something like 0, 0, what if we do like, I don't know, negative 8,000. Negative 8,000. Doesn't let you go up that high. To, I don't know, 8,000. Doesn't let you do it. Okay, so here we can see we tiled it, but it lets us tile it for a region. And it doesn't seem to let us go negative. So that's a very huge problem. So I might just have to manually re-implement parallax again, which is something I'm not looking forward to. I also need to do some research on how I want to handle weapons and stuff on the ship. So I will do some more research on that, but I'm gonna stop this here. But I'm just pretty happy that we got ship movement working. So let me just revert this back to how it was. I'll make this a child of root. I'm gonna delete this node and all of its children. And yeah, so I have a camera that follows my ship. Can't really tell, but wait, I figured it out. What we have to do is we have to, in our sprite, I had to set a larger region. So on my sprite resource, when we go to import, I have to make sure that repeat is set to enabled. And then that will make it so the sprite resource will repeat. And then what we have to do is, once we have that, the sprite added to the parallax layer, we have to enable the region, and we have to enable a region larger than the viewport. Because what was happening before was if we just set this back to, 512 by 512, it looks really weird because now it's going to tile weird. But if we go back to our parallax layer here, and we set the mirroring to equal the size of the sprite, so I've got the background set to go super slow right now. But if we do, look, see how we're moving just a little bit, and our camera's not moving anymore since we're no longer, the ship is not a child of the parallax background anymore. But if I would have kept going, you'll notice that the parallax background will work. Like it just doesn't work. There we go. See, it just doesn't work with tiny images. So what you have to do is you have to make your sprite bigger. So for that, I enabled region, and then I just set it to be 2048 by 2048, which is pretty huge. I mean, that should handle, everything we need basically. And then I'm back to my parallax layer here. I'm setting that to equal the sprite size, 2048 by 2048. So save. And now if I run it, bam, look at that. We are now traveling through endless space. I love Godot so far. So now let's duplicate this. So what we're going to do is, come on, duplicate, Control D, parallax layer 2. The sprite we're going to use for this is the same thing, except what I'm going to do is I'm going to, where is it? Where is it? Come on, let me do a thing. I can flip the H and I can flip the V just to kind of give it some little bit of flavor there. And then for the visibility, so the modulate, if we do, oh, it's alpha right here, dir. So what if we just set like a little bit of a, let's just try that, 24. And then what we'll do is for this layer, the motion, we're going to set it to be a little bit faster. 0.3. Save, and let's run it and see what happens. See how this looks. Look at that. Bam, we have parallax background done already. Yeah. Whew. I'm feeling pretty good about this, man. Do you know how many hours it took me to figure out parallax backgrounds in GameMaker to make it work how I wanted to? And this, you just throw on a few nodes, set some attributes on the nodes, and you're good to go. This is fantastic. This is great. Nice. So let me crank up my ship speed really quick, just so I don't want to rename the ship. Let me just go back to the code here. So max speed, let's make this baby haul 480. Let's crank it. I'll put a little comment here, 240, just so I can go back and fix it. There we go. Look at this. Now we're hauling. Look at that. We are booking through space, and that little layer just adds like a little bit of like a almost not really foreground, but just adds that layer. I bet we can even do some more crazy stuff with it. I mean, I think this looks great. So yeah, I'm pretty happy with that. Cool. Anyway, thank you all so much for watching. I'll see you in the next video.